In this section 2.5, we will talk about linear function, models, regression, and variation. Okay, so in our last two sections, we defined function. We had a different type of function. We know how to graph those functions. Okay, now in this section, we will use this linear function to finish that. I'll help you that after class, okay? So in this section, we'll use the linear function in a real life problems, okay? And the very first model or application that we will use is a linear model. And in this model, we will be using a linear function. And with the help of linear function, we will do a mathematical analysis. Now here, we have an example. At the end of each year, Jocelyn's employer gives her an annual bonus of $1,000. Okay, so she receives annual bonus of $1,000 plus $200 for each year she has been employed by the company. Okay, so at the end of the year, she receives an annual bonus of $1,000 plus $200 for each year she has been employed by the company. Okay, now how much bonus will she receive in the very first year? So if she complete 1 year in her company, how much bonus will she receive? So she gets annual bonus of $1,000 plus $200 for each year she has been employed by the company. So if she work in the company for 1 year, what will be her bonus? $1,200, right? Okay. And what about like after 5 years? So what will be her bonus once she work in that company for 5 years? It will be, so 1,000 plus 200 times 5. So it will be $2,000, right? Okay. Now here we are asked to find a linear function that relates Jocelyn's bonus to the number of years of her employment with the company. Okay, so we have to find a linear function. Okay, and when we need a function, what we need? We need an input, we need an output. Okay, so here we have to identify the input and output. Now what will be the input for this case? So we have a two variable, bonus and the time she work in the company. Okay, so what will be the input and what will be the output?
The amount of time she's been there for the company.
So number of years she work at company is the input and the bonus she get from the company is the output. Okay, so let's call our bonus or our output as a B of t. Okay, so here we have a B of t and this B of t is the bonus. Okay, bonus she receive after working for t years. For t years. Okay, and our t is the input and this is the number of years she work in the company. Okay, so here our t is the input, so this is our input and this is our output. So we have to write a linear function that relates Jocelyn's bonus to the number of years of her employment. Okay, so our t is the number of years of her employment with the company and B of t is the bonus she receives. Now how do we write a linear function? So we know her bonus is $1,000 plus $200 for each year she has been employed. Now how do we write down a linear function here. So to write down linear function, we write down our output, right? Our output is b of t is equals to, so what is her bonus? Now how do we write down her bonus? Her bonus is $1,000 plus 200 for each year. Now if we are talking about t year, what will be the bonus if she worked for t year? So if she worked for 1 year, her bonus is $200, right? If she worked for 2 years, her bonus is 200 times to $400. If she worked for 5 years, her bonus is 200 times 5 equals to $1,000. Now if she worked for t number of year, what will be her additional bonus? 200t, right? So we multiply 200 by the number of year. Okay, and this is the linear function. Okay, so this is the linear function. Our input is number of year, C work for the company, and B is the bonus. B of t is the bonus. Okay, so this is our linear function. Now in part B, use the function. So we are using our function, this function, bonus function, to calculate the annual bonus she receive after she has worked for a company for 8 years. Now, if she worked for 8 years, we are asked to find bonus. Now, are we asked to find output or input in part B? Finding bonus means finding a output, right? So what do we have as a input? What is our t given to us for part B? So we want to calculate annual bonus after she worked for 8 years. So this 8 year is, what is 8? Is it bonus or time? Okay, our 8 is time, so time is 8 years. Okay, and we are asked to find bonus when our time is 8 years. So we are asked to find bonus when our time is 8. When our time is 8 years. So we are actually find b of 8. And this is, we replace t by 8. So we have 1,000 plus 200 times 8. So this is 1,000 plus 200 times 8, 1,600. So this is 1,000, okay? And this is $2,600. So this is the bonus she received after working for 8 years. Okay, so time is the input, number of years you work for the company is the input, and b of t is the bonus. Okay, any question up to here? Okay, now in part C, we are asked to use the function in part A to calculate how long Jocelyn would have to work at the company for her annual bonus to amount $3,200. Now, what we are asked to find here? We are asked to find, or we are asked to calculate how long. How long means, is it time or bonus? Time, right? So we want to find t. So our t is unknown. Okay, so we want to find t. Okay, we want to find time that she worked at the company so that her bonus is $3,200. Now, what is this $3,200? This is the bonus, right? So this is b of t. B of t is $3,200. We are using the equation or a function from part A. So from part A, our function b of t is 1,000 plus 200t. Okay, we want to find t, and b of t is given as 3,200. So let's replace our b of t by 3,200 and solve this linear equation for t. Okay, now we subtract 1,000 on both sides. So this is 2,200 equals to, this is 0, 200t. We divide both sides by 200. So this is, okay, 11 equals to t. So she has to work 11 years in that same company to make $3,200 as an annual bonus. Okay, so once we have a linear function, we can find input, number of years, or the bonus she get after working T years. Okay, any question up to here? So we define a linear function in part A, and to define a linear function, we always need an input, we always need an output. Okay, we have to identify the correct input and identify the correct output. Once we have the input and output, we find the function, and with the help of function, we can find T, we can find B, which is bonus. Okay. So this is for part C. In part D, interpret the slope and y-intercept of this problem. Okay, so our function is, so let me write down the function one more time. Okay, our function is b of t equals to 1000 plus 200 t. Now, since this is a linear function, what kind of graph we get for this linear function? We get a straight line, right? Now, for this function, what is the slope and what is the y-intercept? So what is slope and what is y-intercept? So so how our linear function look like? Our linear equation is y equals to mx plus b. Our linear function f of x is mx plus b. Okay. Now the constant is our y-intercept, and the coefficient of our input, x is the input, and its coefficient is the slope. Now, what is the slope and what is the y-intercept for this function? So what constant do we have? What is the constant we have in this function? Constant number. It's a term without a variable. So what is the constant in that function? 1000, right? So 1000 is our y-intercept. So this is our y-intercept b. And what about slope? Slope is the coefficient of input. Okay, our t is the input, and what do we have as a coefficient? 200, and this 200 is the slope. Okay, now what does it mean for us? So what does it mean by y-intercept equals to $1,000? What kind of bonus is that $1,000? So when will she get $1,000 as a bonus? What we know is that she gets $1,000 plus $200 for each year. Okay, that's what we know. Now our y-intercept is $1,000. What kind of bonus is that? What does that zero means? So yeah, so time zero means what is that? Okay, 0 year means that's the very hard starting date, right? So she get $1,000 as a bonus on her starting date. Okay, so if you are starting now means your time that you have worked for the company is 0. Okay, we defined our T as a number of year that you work for the company. If we are talking about the starting date, the number of year you work for the company is 0, right? So when our time is 0, our bonus is $1,000. It means she received $1,000 bonus as a starting bonus. Okay, that's the bonus she get on her very first day. Okay. Now what about the slope $200? What is that $200 for us? What does it tell us about our bonus? So in starting date, she receives $1,000 bonus, right? On her first year, how much bonus she get? 1,200. In her second year, how much she gets? 1,000 plus 200 times 2, 1,400, right? In her third year, it's 1,600, 1,800, 2,000, and so on. Now, what does that 200 tell us? What is that $200 for her? That's the slope. Now, what does that mean? Slope, it is the bonus that, so $200, so her bonus increases by $200 every year, right? Do you agree? So first day 1000, once you complete 1 year is 200 plus, so 1200. Next year 1400, 1600, 1800, and so on. So $200 is the bonus that increases every year for her. Okay, so 200 is the slope here. So this is the rate of change of bonus for her. Okay, now if this, okay, now let's think. So if this is given to you on your very first day, you get $1000 bonus on your starting day, and your bonus increases by $200 every year. Will you take that offer? What do you think? So your starting bonus is $1000, and every year your annual bonus increases by $200. Do you take that offer? No? Yes? Okay. It's on you. Okay, you can take it or you can decline this. Okay, now this is how we can use our linear function. Okay, so we have this linear function. Using this linear function, we were able to calculate her bonus when after 8 years, and we're also able to calculate time. Okay, so this is how we can use linear function in our real life problems. Okay, any question for this part? Okay, now let's go to the next one. So here we have a table. This table gives us the value of commercial printer at 2 different times. Okay, after its purchase. So we have after 2 years of purchase of printer, the value of printer is $10,000. Okay, we don't know the original cost of printer. What we know here is that after 2 years of its purchase, the value of printer is $10,000, and after 3rd year its value is $9,000. Okay, now in first part we are asked to identify the input and output variables. Okay, now let's call time of purchase as a t. Okay, so let's use t for the time after purchase, and let's call v for the value of printer, okay, after its purchase. Now what would be the input and the output? So what would be the input and output? Output is value and input is time. Okay, so let's call our v as the output. Okay, so our value is a output and t as a input. Okay, now how do we know which one is output and which one is input? Now our output, it is a dependent. Okay, it depends on other variables. Okay, now the value of printer, so on what factor the value of printer depend on? So as the number of years increases, the value of printer is different. Do you agree? So let's consider you bought the printer for $15,000 next year. So when you use the printer for 1 year, the value of printer, it doesn't remain same, right? It changes. There is a depreciation. Okay, so the output, it always depend on some other factor. Okay, our input, it is independent. Okay, time does not depend on anything. Okay, our output, it depend on the other factor. So in this case, the value of printer after its purchase depend on number of year. Okay, number of year of use. So this is so output is always dependent. Okay, our input is independent. So our input is time for after purchase, so t is the input, and value of printer after its purchase is the output. Now in part B, we are asked to express the value of printer. Okay, we are asked to express the value of printer. So here we have to express the value of printer as a linear function of the number of years after its purchase. So we have to express value of printer, okay, v, our value of printer is v, as a linear function of t. Now linear function means we have to find a linear equation. So linear equation is a linear function. Okay, so our input is t here, v is the output. So in general, we use X to represent input, Y to represent output. Okay, so input and output together, it gives a point. So let's say we have our first input is 2 and our output is 10,000, right? So this is 1 point, and second point is our input is 3 and output is 9,000. Okay, input and output together, it gives a point. Okay, so let's think these two as a point. So we have a 1 point here, so 2 10,000 and the 3 9,000 is the other point. Now how do we find an equation that connects these 2 points? So we have to find an equation of a straight line, because a straight line is a linear. Okay, so that's how we can find the linear function. Now what option do we have to find the linear equation? We have y equals to, so this is what we did in section 2.1 2.2. okay, so we have y equals to mx plus b, and the next we have y minus y1 equals to m times x minus x1. So we have these two expressions to find the equation of a straight line. Okay, in both cases, what we need, we always need a slope of a line. So let's find a slope of a line connecting these 2 points. So let's call this is x1, this is y1, so this is x2, this is y2. Okay, so our slope m is y2 minus y1 divided by x2 minus x1. Our y2 is 9,000 minus 10,000 divided by x2 is 3 minus x1 is 2. So 9,000 minus 10,000, this is negative 1,000 divided by 1, and our slope is negative 1,000. So we have an input, we have output. Okay, so input and output together, it's a point. Okay, so we have a 2 point here, and we want to find the equation of a line that connects these 2 points. Okay, which will be our linear function. And to find the equation, we need a slope m. Okay, so we call x1 y1, x2 y2, use the slope formula, and our slope is negative $1,000. Now, so out of these two, which one do we use to find the equation here? First one or second one? Can we use y equals to mx plus b? We know what is m. What about b? Do we know any b? B is the y-intercept. B is the value of printer when our time is 0. Do we know that? Price of a printer when time is 0, or like its purchase price? So we don't have, but what we know a slope, and we have 1 point, right? x1 y1. So let's use this expression to find the equation. So we have y minus y1 equals to x minus x1. Now in this specific case, what is our y and what is our x? So x is the input. Sorry, we have m here. Okay, this is time m. Now in this case, what is y and what is x? X represents input, y represents output. Now in this example, what is our output y? What we use to represent for our output? We have a v, right? So let's replace this by y by v. Do you agree? Because in general, x always represents input. Okay, y always represents output. In our case, we define our v as the output and t as the input. So we replace our y by v minus y1. So our y1 is 10,000 equals to slope. Slope is negative 1,000 times x. X is the input. In our case, input is t minus x1 is 2. So this is v minus 10,000 equals to, let's distribute this negative 1,000. So negative 1,000 times t, negative 1,000 t, negative 1,000 times negative 2, that is positive 2,000. Okay, we have to solve for v. So let's add 10,000 on both sides. So this is 0. Our V is equals to negative 1000 T plus 12,000. So this is the V is the value of printer. Okay, so we can rewrite our output V as a V of T. Okay, since we express our V in terms of T, so we can write V as a V of T equals to negative 1000 T plus 12,000. And this is a linear function. Okay, so this is a linear function for the value of printer in terms of T. So finding linear function means we are finding a linear equation. Okay, to find the linear equation we need a slope. Okay, so you find a slope and use a point slope form to get a linear equation. Okay, any question up to here? So this is for part B. Okay, so this is the answer for our part B. Any question? Now in part C, we are asked to use this function to find the original purchase price of a printer. Now we have a two variable. Okay, we have a V as a value of printer. Okay, and we have a T, that is the number of years after its purchase. Okay, that the number of years of use of printer. Now if we are asked to find its original purchase price, what will be T? So our T is the number of year of printer use. Okay, like if we are using our printer for 5 years, then T is 5. So if we are talking about the print, if we want to find the original purchase price, what will be T? I'm sorry? 1. So T equals to 1 means that is the 1. So that is the 1 year after purchasing the printer. So it has to be 0. So if you purchase the printer now, the number of year of its use is 0, right? So in part C, so at first we are asked to find original purchase price. Okay, it means we have to find V. So this is what we need to find, V. Okay, and to find the original price, what is our input? Input is the time after purchase. The time after purchase will be T will be 0. Do you all agree? We defined our T as a number of year after its purchase. Okay, so that is our T. And we are trying to find original price. Okay, original purchase price means we want to find the price of a printer on the purchase date. Okay, so on that purchase date, the time after purchase will be 0. Now let's use our function from part B. So our B of T is negative 1000 T plus 1200, and let's replace every T by 0. So V of 0. Okay, so V of 0 is the original purchase price. This is negative 1000 times 0 plus 12,000, and this is $12,000. And this is our V of 0. V of 0 means it's a original price. Okay, original purchase price. So here we have a linear function, and we use our linear function to find the original purchase price of a printer, which is $12,000. Any question? Yes.
Wouldn't you just be able to grab it and then go backwards and figure it out?
You can use a graphical method. Okay, we get a straight line. Yeah, you can use a graphical method too. Okay, but here it does not tell us to use a graphical method. We can also graph. Okay, let's finish part D and we'll try to graph this linear function. Okay. Okay, now let's start number D. In number D, assuming that the value of printer is a linear function of number of years after its purchase, when will the printer's value reach $0? Now the question is when will. Now is it V or T? What variable are we asked to find? When will the printer's value reach $0? So when means it's a time, right? So we want to find time. So time is unknown. Now what about that $0? What is that $0? What variable? Is it V or T? V, right? So our V of T is $0. So use the same equation, same function. So our linear function V of T is negative 1000 T plus 12,000. So our V of T is 0. Value of printer is $0. And we want to find the time after its purchase. So let's solve this equation. We subtract 12,000 on both sides. So negative 12,000 equals to negative 1000 T. Divide both sides by negative 1000. And this is 12 equals to T. So after 12 years of its purchase, the value of printer will be $0. Okay, that's what it tells from our linear function. Okay, so it takes like 12 years to reach the value of printer to be $0. Now, in this function, what is our slope and y-intercept? So what is slope for this function? Negative 10,000 is the slope, right? Now, what does it mean for us? So what does it tell for this example? So what is that negative $1,000 is? That's the slope. Now, what does that mean? It means the value of printer decreases. Since it's a negative means it decreases by $1,000 each year. Okay. In our previous case, our slope was positive $200. In that case, her annual bonus increases every year by $200. In this case, our slope is negative. Okay, negative means the value of printer decreases by $1,000 every year. Okay. Now, what about the y-intercept? So, what is y-intercept for this function? $12,000, right? And what is this $12,000? This is the original purchase price of a printer. So, this is the value of printer when T is 0. T is 0 means that's the purchase date. So, that's the price of a printer during a purchase date. Okay, now let's go ahead and graph this function. Okay, any question up to part D? All right, so let's graph this function. It does not ask us, but let's graph it. Okay, so our function is V of T equals to negative 1000 T plus 12,000. Okay. Now to graph, we get a straight line. We need at least 2 points. So our input is T, our output is V of T. Okay, and T and V of T together, it gives us a point. Now, what kind of value? Our T is a time. Now, what kind of value we can pick for T? Can we pick T equals to any real number? Can T can be any real number? T is the number of years. Can we take T equals to negative number?
No.
T can't be negative, right? So where do we start? We start T equals to 0. Now what does that mean? Means that's the purchase date of a printer. Okay, T equals to 0 means purchase date. So when our T is 0, let's find V of T. You replace T by 0, we get 12,000. Okay, so 0, 12,000 is 1 point. Now let's take T equals to What T you want to take?
One.
1. Okay, so if T is 1, then it's 11,000. So 1, 11,000. So let me take one more. So what if our T is equals to 12? So what is our output? You replace T by 12. What do we get? V of T? We get 0, right? So 12, 0 is the next. Now, can we take 13? So what happens if our T, like what happens to the value of printer in 13th year? So what we know, on the 12th year, its value is $0, right? So what happens on the 13th year?
It's still 0.
It's still 0, right? The value of printer can't be negative, right? So we can pick our T any number in between 0 and 12. Okay, now let's go ahead and graph this. So to graph, we need our horizontal axis. In our case, horizontal axis is time. Okay, so this is time. Vertical axis is value of printer V of T. So we have origin, that's the starting point or the purchase date. So 0 to 1200. Okay. So here, so let me call this is 2000. Okay, this is 2000, 4000, 6000, 8000, 10,000, 12,000. Okay, so first point is 0 to 12,000. So this is here. So we have first point here. Second one, okay, let's say this is 1 year, 2 year, 3 year, 4 year, 5 year. Okay, so this is 1, 2, 3, 4, 5. Okay, let me call this is 12. Okay, 11,000. So this is 1, this is 12, this is 10,000. So we have second point here. Okay, and 12, 0 is here. Okay, now let's connect all these 3 points. We get a straight line. Okay, now can we extend this graph on the left and on the right? Can we extend this graph on the left and on the right? So extending graph on the left means our T is negative. Is it possible to have T equals to negative number? No, it means we cannot extend. And extending on the right means our T will be 13, 14, 15. Now, what happens to the value of printer when T is 14? It doesn't have its value, right? Okay, so there is no output. So our graph cannot be extended on both sides. Okay. Now, what would be the domain for this case from this graph? Can you tell me the domain? So domain means what are the input? What are the possible input we can use for this function? So what numbers can we have as the input for this function? So you are looking along the x-axis. So what is the start x value for a starting point of this graph? Our graph is starting at 0. This is the x value, okay? And at what x value the graph is ending? At 12. Okay, so from 0 to 12, this is a domain. And range, we are looking along the y-axis. Okay, so what is the y value for the starting point for this graph? What is the y value for this? So we have our graph is starting here, right? So what is the y value for this point? 12,000, right? And what is the y value for this point? 0. Now how do we write an interval? Is it 12,000 to 0 or 0 to 12,000? It's always a small number first, then big number, okay? So our range is every y value from 0 to 12,000. And this is the range. So this is how we can use graph to find the domain and range. Okay, now we have very similar in our third example. Okay, can I start the next example? Okay, are you still writing easy? Okay, so let me give you a hint for that and we'll do. So in third example, we are asked to find the linear function f whose input and output values are given. So our x is given, f of x is given. Okay, we have an input, we have an output. So you write down the input and output together. Okay, so we get 2 points. Find the slope, use the point slope form. Okay, the very similar to our second example, and you will get the function. Okay, now here in part 3, so our input is x, our output is f of x. So let's write down our input and output together. So 1.3 is input, 4.5 is output. We have 1 point. So for the second, 2.6 is input, 1.9 is output. So we have a second point here. So finding a linear function means we are finding an equation of a line joining these 2 points. Okay, and every time if you are finding an equation of line, we always need a slope. So let's call our first point as a x1, y1. Let's call our second point as a x2, y2. Now let's find slope. Our slope m is y2 minus y1 divided x2 minus x1. Okay, now you substitute your y2, which is 1.9, minus y1, which is 4.5, divided x2. x2 is 2.6, minus x1 is 1.3. Now I need your help. So what is 1.9 minus 4.5? It's negative, that's a 15, 6. Is it 2.6, negative 2.6? Okay, thank you. In the next, we have 2.6 minus 1.3, that is 1.3. Okay, so negative 2.6 divided by 1.3, that should be negative 2. Our slope is negative 2. Now let's use point slope form. Y minus y1 equals to m times x minus x1. We have y. Okay, now here, what is our y? In this very specific example, what is y? Y is the output. Now what do we have as output in this table? No, in general. So what they have used for the representation. So what is our output in this table? F of x. Okay, your x is the input and f of x is the output. Okay, so let's replace our y by f of x. Okay, that's our output. Minus y1, that is 4.5, equals to m, which is negative 2. Our input is x, so we have x as it is, minus x1, that is 1.3. Now let's solve this equation for f of x. So we have f of x negative 4.5. We distribute negative 2. So negative 2 times x, negative 2x. Negative 2 times negative 1.3, that is positive 2.6. Now we add 4.5 on both sides. And f of x is equals to negative 2x plus, so that's a 1. Okay, that should be 7.1. And this is a linear function, okay, for this given table.